In this video, I will talk about Boolean expression and Boolean algebra. So after this one, you will understand what are they and how do we do something like true and false, what is the value of true and false or true or false, and what are the symbol and what are the logic gates, what do they look like, and how do they function. Okay, now let's have a look at this example. Let's have a look at this image, and I have a Boolean expression in here. So what is an expression, first of all? So in mathematics, an expression is a statement involving at least two different number or two different variable and at least one operations. Okay, so I have a statement which is it is sunny and everyone have an umbrella. And the operations that I have in here is and. Okay, so I have two Boolean variables. One is it is sunny. Another one is everyone have an umbrella. So this one is called a Boolean expression. The statement it is sunny can be either true or false. And the statement everyone have an umbrella can be either true or false. If something can be true or can be false, which means it can take two different values, either one of them, then we call that a Boolean variables or Boolean values. So a Boolean values can be either true or false. Okay, so use your logic. Is this expression true or false? Okay, the whole statement is, the whole expression is it is sunny and everyone have an umbrella. Okay, so let's think about this for a few seconds. Have a look at this image. Is this true or false? Okay, I hope everyone have an answer. This expression is false. Okay, so this is false, and why is that? Let's say I have it is sunny. It is sunny is a statement, and I assign that to a variable called a. This statement is obviously false because you can see it is raining and it is not sunny. And everyone have an umbrella. I will assign the value of this expression to the variable b, to the letter b. And you can see the value of b is true because having a look at this image, everyone have an umbrella. Okay, if you don't know why this is false, then it's just common knowledge, common logic. So if someone tell you it is sunny and everyone have an umbrella, that's not true. It's logic. So instead of writing it is sunny and everyone have an umbrella, I can use the letter A and B to represent these expressions. I can write it as A and B. And I can write A and B equal false. Okay, this is another way to represent this expression. Okay, so what expression would be true in this case? Okay, the expression that would be true would be it is rainy and everyone have an umbrella. Or you can say it is not sunny and everyone have an umbrella. That can also be true. Okay, now we know what is Boolean expression. Let's have a look at the gates, the logics that we use. So the logics we use in here is the AND operations. This can be called an operator. And let's have a look at the AND logics. Okay, let's consider another example. I have a pin and a couple wire, and this is a clipboard. The clipboard is made of metal, so the electrical signal can go through the clipboard. Okay, so let's say this clipboard is not connected. So I would say this clipboard is false. Whether it is connected, I would say this one is false. And this is true because it is connected. So I can represent this whole thing, this whole design, by writing false and true. False and true. False is the open gate and true is the closed gate. And the value would be false because, as you can see, there are no signal going through the bulb. So the bulb is currently turning off. To represent false, I can use the number 0. And to represent true, I can use the number 1. And 0 and 1 equals 0. Okay, now let's have a look at this example on your right. You can see the signal can go through the bulb because both of the gate is closed. So the signal can go through gate number 1 and gate number 2. So to write the statement, to write the logic, I can do true and true equal true. Or I can say 1 and 1 equal 1. And this one is the AND logic. So in an AND logics, all of the statement need to be true in order to the final thing to be true. Okay, now every expression that you see can have a truth table. So what is a truth table? This one is called a truth table. A truth table will represent all the possibility and the value of each possibility. A truth table will output all possible inputs of a Boolean expressions. Okay, so let's say I have two clipboards. One is called A and another one is called B. So in this example, I have two variables. One is A and one is B. And 0, remember 0 is false, which means the gate is open. A and B is the value of the Boolean expression. A and B is a Boolean expression. And if the bulb is turning on, if it is lighting up, then it will be 1. Otherwise, it will be 0. And this truth table represents an AND logic. Okay, so 0 and 0 will be 0. Because if both of the gate is open, then of course the bulb will not be turning on. If one of the gate is open and one of the gate is closed, 0 and 1, the final output will still be 0. The bulb will not be turning on. The only time that the bulb is on is that both of the gate is closed, which means 1 and 1 is 1. Okay, 1 and 1 equal 1. And this one is called a truth table. So if you have another variable called like C, then you need to write all of the possibility and the value of it. Okay, let's say I have three variables, three different clipboards. Opens mean false. So to represent the first one, I will write false and true and true. So false and true and true. And the value will be false because as you can see, the signal cannot go from this point to the other point because we open the gates. The pictures on your right, you can see that all of the gate is closed. So the signal can go from one point to another, which means the bulb will be turning on. And to represent this diagram, I can write true and true and true equal true. Okay, so from this example, when talking about AND gates, the way that I remember it is that everything needs to be true. So all of the variables need to be true for the final thing to be true. So if one thing is false, the whole thing will be false. Okay, that is the AND gate. Now let's have a look at the OR gates. Let's have a look at this expression. Tuan is a lecturer and Tuan is a female. It is true or is it false? Okay, so someone tell you Tuan is a lecturer or Tuan is a female. This one is a true statement because one of the statement is true. Okay, so if you don't know why this is true, then I think it's just common logics. But yeah, I think you need to understand why this statement is true. So if I have an OR logics, one thing can be true. If one thing is true, then the whole thing will be true. That is the characteristic of an OR logics. Now I can represent that one using this diagram in here. Okay, so I have two gates. So false and false, open and open equal false. Now if one of them is open, another one is closed, then the signal can go from one to another, which means false and true, false or true equal true. Another example is if both of them is close, then the statement would be true or true equal true. Okay, if I want to represent the OR logic with 3 variables, then I can have 3 gates in parallel like this. So this one will be, I can write it as false or true, false or true. And because the bulb is on, the final thing will be true. The final value will be true. Or I can write 0 or 1, and the final value will be 1. This is the truth table for 2 variables of an OR logics. So if 0 or 0 will be 0, 0 or 1, which means one statement is true, then the final one, the final A or B, would be true, which means it will be 1. Next one, 1 or 0 will be 1, and 1 or 1 is 1. So the thing that I use to remember the OR gates is that just one variable or one statement is true, the whole thing will be true. This is very important because when you do programming, you need to write a lot of conditional statement where you have to merge different statement and logics together, and you need to have a good understanding of AND logics and OR logics. Okay, now comes to the logic gates. Instead of writing A and B or A or B or not A or not B, you can represent that using symbol. And the symbol that we are using in here is called gates. Okay, so why do we use gate? Because it's easier to see and it's easier to represent when the logics is complicated, when we have many variables. And when we do digital design, for example, in this unit, we do it in Logisim, which is the software that we are using. We do everything in logic gates. These are called the logic gates. Okay, so logic gates is basically different way to express AND or not logics. And physically, a logic gate is a device that performs binary function. It's an actual device that can perform the binary function. What is binary function? It's a function between binary numbers. Okay, so let's have a look at the NOT gates. Okay, NOT gate, you can write it as a rectangle, a triangle, and then use a little dot, a little circle. Okay, so from 0, if I make it go through the NOT gate, the result that coming out of the gates would be 1. This NOT gate will reverse everything. And this is the truth table for the NOT. So A is 0, NOT A will be, oops, I make a mistake here. Okay, so if, if this is A is 0, NOT A will be 1. And if A is 1, then NOT A will be 0. Remember that it reversed everything. Okay, this is my mistake, my bad. To represent an AND gate, you will write this symbol. It's like a curve in here, just like that. And this AND gate will check if everything is true or everything is on. So if you have multiple input into the AND gate, the only times that the output is true is that everything is true. And this is how you draw the OR gates. You draw a little curve in here, and then another curve like this. Okay, so apart from NOT gates, OR gates, and AND gates, we have some other gates, like we have XOR gates, and we have XNOR gates. So let's have a look at the XOR gates. This is quite common, and I will explain why it is common. So in an XOR gate, let's say I have 2 variables A and B are the 2 input that will come to the gates. Now let's have a look at this truth table of an XOR gate. So 0 XOR 0 will be 0. So false XOR false will be false. And 0 XOR 1 will be 1, 1 XOR 0 will be 1, and 1 XOR 1 will be 0. Okay, so if it is an OR gate, then this value right here will be 1. But because this is an XOR gate, this value will be 0. Okay, so the way I remember the XOR gate is that if you want to check if two values are different or similar. So if you have two variables A and B, then if two values are different, then the result will be true. But if two values are similar, for example 0, 0 and 1, the final value will be false. Now an XNOR gate is the opposite of the XOR gate by writing just the N letter in the middle. And it's just the opposite. So it checks if two values are similar. So the XOR gate is to check that if two values is different. The other one is to check if they are similar. And this is how you draw them. You have this part, this curve, like an OR gate, but then you have this curve, and then you have a little dot. Okay, some other gates that we have are called NAND gates, and we have NOR gates. Okay, so another thing I want to tell you is that to represent an XOR gate or XNOR gate or any other gates, those things can be represented using a combination of these. So if you think about how to design it, you can do every logic possible by using just NOT, AND, or OR gates. You can mix and match them, you can design them to create any gates that you want. So for example, XNOR gate, it's just the XOR gate followed by the NOT gates. And then the XNOR gate, you can actually represent them using just AND and OR. Okay, some other gates that you have are called NAND gate. NAND gate is not AND, so you have an AND gate, which is this symbol, and then you just reverse the output, and it will become the NAND gate. So the way to remember this is you have an AND gate, and you write the letter N, then you reverse everything. Similar to the NOR gates, you have an OR gate, and if you want to reverse the output, you just write the letter N, or what you can do is you can draw a little circle to represent that it will go through a NOT gate before it generates the output. Okay, last thing is that instead of using gate to represent AND, OR, and NOT, so different logic expression, Boolean expressions, you can actually use symbol to represent them. So if you are using symbol, that means you are doing algebra symbol. So these are called algebra symbol. So a NOT gate is represented in a triangle followed by the circle. But you can either write NOT, or you can draw the symbol, or you can use algebra like this. So all of these three options represent a NOT gate. So this is not A, this is not A, this is not A. One way is use the tilde. This is called the tilde. This curve symbol is called the tilde. This is exclamation marks, very common in programming languages. And you can write A with a dash on top of it. All of these represent the same thing, which is not A. To represent an AND gate, you can write A and then dot B, or someone can write A and then times B. The dot can be in the middle or underneath. If you want to represent an OR gate, then you use a plus. So A plus B would be A or B. Now let's have a look at this diagram. I have two variables A and B going through a NOT gate. Going through an AND gate. Okay, this is an AND gate, just like this one. So AND gate would be A dot B. Okay, so I will do it step by step. Because A and B go through an AND gate, I will write A dot B. Okay, so A dot B is this point. This point coming to an OR gate. And an OR gate is represented using the plus symbol. And the output of A dot B will be combined with the variable C. So what I write is I will write A dot B, which is the output of A and B. Combine that with the C in an OR gate. So I will use plus C. And then everything goes through a NOT gate. So I will write a dash on top of everything. And last thing is that if you want to represent an XOR gate, remember that an XOR gate is to check whether two values are different. Then you can write it as a plus and then a circle out of the plus. So this one represents an XOR gate. And then let's say if you want to represent XNOR, XNOR is the opposite value of XOR. So the output of XOR, you make it go through a NOT gate, it will become an XNOR. You can just write a dash on top. But these are all the things that you need. A dash, A with a dash on top, A dot B, A plus B, and A, this symbol B. These are called the algebra symbol. Okay, so the question that you may ask is, why do we need to learn all of this? So all of this is very helpful because in order for a computer to function, they need to go through a lot of AND gate, NOT gates, XOR gates to manipulate the bits, which is a 0 and 1, to get the desired output for any functionality that we want. So during the first 6 weeks of this unit, you will be doing a lot of program in Logisim, where you will design a lot of XOR gate, AND gates, and then later on you will understand why do we need to do all of this. But the whole point of all of this is to manipulate 0 and 1. That's basically what it is. And why do we need to create a bunch of symbol for different logics? Is that we need a way to communicate the design to another person. We cannot just say A and B and C, not B, not C. Sometimes we want to represent everything in a diagram. That's why we need to learn about this symbol.